In this video, we're going to look at the three different laws of motion that we looked at on the test. So the first question says, Newton's first law of motion states. Well, Newton's first law of motion is an object at rest will stay at rest, while an object in motion is going to stay in motion. So for example, if you look at this picture on here, an object in motion wants to stay in motion. So as this guy is traveling on the motorcycle, he comes to a complete stop, which is this wall. His body wants to continue going the direction that it was going. So although the motorcycle stops, he's going to continue to go forward. So it's kind of like when you're in a car and someone slams on the brakes. Your body naturally goes forward because an object in motion wants to stay in motion. The other part of it is an object at rest is going to stay at rest. So for example, if there's a ball on the ground, it's going to stay at rest until an object is acted upon it. So maybe it's your foot kicking it. And so again, Newton's first law is an object at rest will stay at rest, while an object in motion is going to stay in motion unless acted upon by another force, also known as the law of inertia. Newton's second law of motion states a force acting on an object is equal to the mass times acceleration. For this law, it shows that if you exert the same force on two objects, so we're putting the same amount of force towards two different objects, one of them being a car and one of them being a rock, you will get different accelerations, which just simply means a change in motion. The effect or the acceleration on the smaller mass, which is going to be this one, is going to be much more noticeable. So again, if we're applying the same amount of force to two different types of mass, one being much larger than the other one, the smaller mass is going to have a larger acceleration. Which of Newton's laws best explains why a rocket can be launched into space? For this one, the answer is D. For every action, there is an equal and opposite reaction. Forces are found in pairs. Think about the time you sit in a chair. Your body exerts a force downward that the chair needs to exert an equal force upward or the chair will collapse. It's an issue of symmetry. Acting forces encounter other forces in the opposite direction. So for example, with the rocket, all of the pressure is pushed downward, that's your action, and the outcome of that, or the reaction, is that your rocket launches upward into the air.